Hi, so in section 8.3, we're testing a claim about a mean. And in this case, we're going to be focusing on the case when sigma is not known. And if we recall, this is going to be the more common situation. In other words, if we don't know what a population mean is, then it's likely that we don't know the population standard deviation either. So the best we can do is take a sample of that population and then use the sample standard deviation instead. Okay, which means that we're going to be using the student's t distribution to model the sampling distribution of x bar. Right, so x bar being our sample mean, right? We're going to look at using a sample mean to estimate our population mean, and in this case doing it with a hypothesis test. And here's the basic requirements. The sample is a simple random sample. Value of the population standard deviation is not known, like we're assuming here. Either both of the given conditions are either or both of the given conditions are satisfied, where we have the population is normally distributed or our sample size is greater than 30. And the basic idea with performing a hypothesis test, in this case, for simplicity, let's say we have the given null hypothesis that our population mean is equal to 10, and the alternative hypothesis that our population mean is less than 10. And now let's suppose we take a sample, and in our sample mean we get a mean of 10. Well, that doesn't seem unusual. If our population mean was 10, then that would seem totally fine. So in that case, we would fail to reject the null hypothesis. If we get a sample mean that's slightly smaller than 10, well, that doesn't seem too unlikely either. We can expect there's some variation between our different samples. So getting one that's just a little bit smaller than 10 doesn't seem that unlikely. So in this case, depending on the situation, it doesn't seem like just being a little bit smaller than 10 would be enough to reject the null hypothesis. If it's greater than 10, well, here the alternative would be that it has to be less than 10. So saying that it's greater than 10, we would still fail to reject. So the only case that we would reject the null hypothesis would be if if our sample mean is less than 10 by a lot, in which case then we would reject the null hypothesis, and that would be used as evidence to support the alternative. So of course we have these requirements that we're dealing with a simple random sample, and the the null hypothesis is always going to be of the form mu equals to some value that we're assuming to be the population mean. And then the alternative hypothesis will take on one of the three forms. Either it's less than mu naught, greater than mu naught, or just simply not equal to mu naught. We have our significance level alpha, and when we're computing the test statistic, we're always going to be doing a t-value, right? Because in this case, our assumption is that we don't know what the population mean, what the population standard deviation is. So we're going to use t-scores. So we'll take x bar minus the claimed value from mu divided by the standard deviation over the square root of n, and so that'll be the standard deviation of our sampling distribution, which in this case is the t distribution. Okay, and then from there we'll find a critical value or a p-value. In this case I'm going to focus mostly on the p-value method. And then once we've figured out our p-value, then we can make a decision about whether to reject or fail to reject, and use that to draw a conclusion about the original claim. Here are the three possible tests. Remember, if we have less than symbol in our alternative hypothesis, we're doing a left tail. So our p-value would be the area that's to the left of our test statistic. If we have mu is not equal to some value, then in our alternative hypothesis, then we're going to be doing the two-tail test, where we're finding the area of the values that are less than our test statistic on one end and the values that are greater than the test statistic on the other end. So this would be the opposite sign down here. And then the right-tailed test, if we have a greater than symbol in our alternative hypothesis, then we're going to be finding the p-value by computing the area to the right of our test statistic. And this will be the method that I'll focus on, but the critical value method would also be valid here. You would find the critical value, and then that would define a critical region, and if you see your test statistic falls within that critical region, that would tell you that you're going to reject your null hypothesis. If it lies outside of the critical region, then you fail to reject. Whereas here, if I'm computing my p-value, I'm going to reject in the case when the p-value is less than alpha, and I'm going to fail to reject if the p-value is greater than alpha.